All right, welcome again to another lesson here. Again, this is just going to be kind of a quicker one, hopefully, and we're just introducing some of the math that is involved in chemistry. Obviously, later on in the year, there will be much more math, but this is kind of some of the basics as we go through. We already talked a little bit about conversions in the metric system and how to go back and forth from one unit to another, and we're going to continue to work on that this next week. But we also want to look at some other measurements and some concepts and some definitions. So make sure that you have notes and you're writing some of these things down because these are important as we go through. What we're going to discuss is measuring in units, and there's a couple key concepts when we talk about measuring. It's not just as simple as that you measure out the volume of something or you measure the length of something, but there's also a couple terms in there that we're going to talk about that we have to compare against. Some of the units we've already kind of dealt with in class, and so we're going to kind of just kickstart this and kind of jump past that. We'll review just a tad bit, but for the most part, we're going to deal with new stuff. First of all, what is measurement? Well, measurement is the act of comparing an unknown quantity to a standard unit. So for example, if you wanted to measure your table at home would be the unknown quantity. You don't know how long it is. You don't know what the length of it is. And so you would take a standard unit like a meter stick, and you would compare how many meters is that. Or if you didn't know, if there was something that you wanted to find what the mass of it is, maybe outside you find a beautiful leaf, since we're approaching the fall and the leaves begin falling off the trees, and you wanted to know what the mass of that was, you would have to compare it to a standard unit such as a gram. And so we know what a gram is and what that makes up, and so we would have to compare it to that. So that's what measurement is comparing something to something that's already known, to a standard. And we dealt with this the other day, trying to convert. So let's say you start with 256 milligrams. How would I then get into grams? Well, we said the first thing that you do is you kind of create a fraction. Some people call this bridge notation, which is fine. That's another way to describe it. And so the first thing that I'm going to deal with is I'm going to deal with my units. And I want to take care of, this is bridge notation here. I want to take care of my units first. So you notice we put mg, milligrams, on the bottom so that it cancels out with the top unit. So those 2 grams, you notice, cancel out. And then the next thing that we do is we go to our chart that we talked about in class the other day, and we want to be in grams, so we put grams on top, and then we ask ourselves, which is grams larger or is milligrams larger? Well, grams is larger, and so it gets the value of 1, and then you work your way down the chart till you get to milligrams, and you add a 0 for each step you go down. And so in 1 gram, we find out there's 1,000 milligrams, and you may want to follow along with me in your chart that we did the other day in class. And so then if I work it out, kind of here's the math that's involved. You'll notice my milligrams have canceled out, and so what am I left with? 0.256 grams is the math there. That's review from what we did the other day. Continue to work on your worksheet to practice that, and hopefully that will begin to click, and we'll do some more over the next week or so with that. All right, what do we want to deal with today? Well, one of the problems that we want to recognize is that there is always some uncertainty involved with any measurement that you make. So as you do a lab and you're measuring something, there's a certain amount of uncertainty. There's something we don't know. For example, and a lot of that's you're limited to the equipment that you're using. So for example, our electronic balances that we use when we measure the mass of something, they measure to 1/100th of a gram, which is good. But if we wanted to know it to 1,000th of a gram or 1,000,000th of a gram, we don't know that. Anything beyond 1/100th of a gram, we're uncertain of. So there's some uncertainty involved in any measurement. And a lot of it's dependent upon the equipment that you're using and how precise it is. So there are some things that we have to keep into consideration as we do that. So the first definition that we want you to know. There's really two words. One is accuracy and one is precision. We're going to deal with accuracy first because they are different from one another. So when I'm talking about accuracy, what am I talking about? Well, accuracy deals with, as you deal with a numerical evaluation, how close the measured value is to the actual or accepted value. So you're comparing it to a standard. So accuracy is how close do I meet that standard. And usually the way we do this, okay, so that's the definition. The way we typically do this is there's a mathematical formula that we're going to use in class, and this is something that you need to get down. You will use this on multiple labs. We'll do this on the test that we have on this section, dealing with math in science, and that is what we call percent error. And here is the percent error formula. It is the observed value minus the accepted value divided by the accepted value. And the observed value would be what you get. Okay, that's your experimental value. So you do a lab, you get some data, that's your observed value. The accepted value is the standard. In other words, here's what you were supposed to get. Here's what the accepted value is. For an example might be you're trying to calculate the density of water. Well, we know what the density of water is. That's been experimentally determined many times to very precise degrees. And so you may do a lab and you may observe, well, here's the density of water. Well, how well does your experiment measure up to what is the accepted value? And so you plug your number in, subtract it from the accepted value, divide by the accepted value, and you'll get a decimal. And that's why we multiply by 100% there, or 100 basically is what you're going to multiply by to convert that decimal into a percentage. And so hopefully the number that you get is relatively small. It may be 2% or 3% or 5%. If you're starting to get larger values for percentages, 10%, 20%, 50%, those are not good. And the acceptable percent error varies from experiment to experiment. Most of the experiments we do, 5% error will be totally acceptable. Not an issue, not a problem. There will be some experiments, depending on who's doing them and the equipment maybe that they're using and the technology they may have at their disposal, that their percent error is less than 1%. And if it's 1% or more, it's not acceptable at all. 0.5% error may be not acceptable in some situations. So it depends on what the experiment, the technology you have at your disposal, all of those different kinds of things. Here's kind of a shorthand way of writing that same formula. O stands for observed value minus A, which stands for accepted value. And it is an absolute value, you'll notice there, because there is no such thing as a negative percent error. So we don't need to deal with negatives. And that is divided by your actual value or your accepted value. The other aspect, so that was dealing with accuracy, comparing it to a standard. Precision is a little bit different, even though a lot of times we may kind of use those words interchangeably sometimes. They're not actually the same. Accuracy deals with comparing to a standard and how close did I come to that standard. Precision has to do with how repeatable a measurement is. So in other words, am I getting the same results as I do that experiment? Or am I getting results that are completely different? One is, I have an answer over here, and then one answer is completely way off from that one. That's precision, is being able to repeat your experiment. And even if my answer is not accurate, I'm able to repeat it and get the same answer. And so that may tell me something about my experiment. My experiment's not accurate, but it is precise. I am getting the same results, so maybe the problem is in my procedure. And so I need to fix something there. Or maybe the problem is with the accuracy of my equipment, or something along that lines. Here's just kind of a quick, you have this picture in your book as well, and it kind of just gives you a visual idea of what precision and what accuracy is. You have the first picture there on the left. It's not accurate. They're aiming for the bullseye. They totally miss. So compared to the standard, it's way off. But it is precise because he did hit the same area. He was consistent on that. The second one there is more or less accurate. He did get close to the center, but it's not precise. You know, he kind of hit in a number of different spots. The third one there, he is accurate and precise. He got in the same spot, and it hits the standard. And then the last one there is, of course, neither accurate nor precise. And you can kind of get a laugh out of that one there. All right, the next one here, dealing with kind of steps in problem solving. How do you approach problem solving? How do you work out steps, and what is kind of the thinking process to that in any time you have a problem in front of you, whether it's a math problem, whether it's some kind of word problem or something like that. Step one, read the problem, which is kind of no duh. Two, determine the method of solution. In other words, where do you kind of really determine where do you want to get to? What is it, the answer that you want to find, and then how are you going to get there? What steps do you need to take to arrive at that solution? Do you need to convert something? Do you need to go from, let's say, grams to milligrams, or what do you need to do in order to do that? Step three, okay, the third step is choose the specific tools that you're going to use, whether that be a math problem or whatever. Step four is to set up the problem and then calculate the problem out. So those are really basic, generic steps. And I will, whenever we have problems in class, I'm going to give you kind of a step-by-step how to set each thing up. So don't worry on that. These are just kind of a generic steps here. All right, the last thing, I just wanted to introduce this to you, and I know we briefly went over it in class when we were talking about in one of the videos that you watched. We talked about density briefly as a physical property. Density is a mathematical formula, and we will be calculating with it, and it's defined as a substance mass divided by its volume. I believe the formula right here, it's D equals M over V. M, more often than not, is written in grams. V, volume, is more often written in milliliters or sometimes centimeters cubed, which are the same thing. They're just different ways of writing it. One is, they're both units of volume, and they both equal the same amount. 1 milliliter is equal to 1 centimeter cubed. They're the same thing, just different ways of measuring it. And you'll notice there are three variables here: density, mass, and volume. So all I need to know is two of them to solve for the third one. So if you're solving for density, I would need to know mass and volume. If I was solving for mass, I would need to know density and volume, and then I can just rearrange it like an algebraic equation from there. And basically what this is measuring is comparing how much stuff can I fit in a given space. Is more or less what we're comparing. So we'll do some problems dealing with density and calculating density. Either solving to find density, or sometimes solving to find volume, or sometimes solving to find mass. And we'll practice with some more of that in class. All right, that's it for today.